Okay, now we're going to do a research project on wood. Wood is a very, very common construction material in our area. It's not as used in some parts of the country, but in California and the Western United States in particular, wood is a very, very important construction material. We're going to take 2 weeks to get this done. So, and this overview is going to cover what we'll do in the first week. So, what we're going to look at is key information about construction lumber and dimensioned lumber sizes and span charts. I'll speak briefly about them, and then you'll get a chance to look up some specifics. And then we'll talk about what's called engineered wood products. Okay. Um, and then in the next week, the second week, I'll give you another overview about how to do a material and labor estimate and how to look at damage to wood and some maintenance options to keep things um, safe and long lasting. Safety is number one. As always, the whole reason to know about materials is public safety, public safety, public safety. Safety comes first. To design something and have it be unsafe is the antithesis of what we want to do. We want things to be safe. After that comes functionality for as far as well, actually aesthetics, looks, and cost, and things like that. Got to be safe to begin with. And so there's a lot of standards about that. Let's take a look and see what's available to you. We're going to look at key information about lumber, and we have a product use manual, dimension lumber by different species, lumber sizes, and lumber design values, and then so on and so forth. Let's see what we're supposed to do as we go through the week. The first one is summarize WWPA, Western Wood Products Association. They are one of the primary um, organizations that provide information, provide training, and actually they are the people that certify the grading system so that when you buy a piece of wood, you know what it's going to be like and what it's used for and what it can do. Wood is very interesting. When you make concrete, it's pretty much if you specify it, you know what it's going to do. Wood is far more variable. It's made from a living organism, and so it doesn't grow perfectly the same every time. As a matter of fact, it grows incredibly different each time. So the WWPA can give you a grading system that helps you know that when you choose a piece of wood that is graded in such a manner that it will be useful and safe and strong. Mostly what they do is they look at the number of defects and the types of defects and the size of defects in a normal piece of lumber. Okay, and since we've just said there's a lot of differences in wood, you're going to see that there are some common species that we use in framing, and you'll have a chance to look those up and find out about how they grow and where they grow, and so that's this one too. So that's the first part of it. You're going to look that information up. Where would we find that? A lot of that is in this use manual. And again, you can use Control F to look through, but here's about the WWPA. And here's some good information about what's in this manual. And then, this is about where things grow and a little bit about the grading system. There's more than one resource about the grading system. But this is really, really good to understand and know. And when you go to a lumber mill or a lumber store, even if it's Home, Cheapo, or Lowe's quality, then you will find on each piece of wood some sort of a stamp. And if it's framing lumber, the stamp will look one way. If it's decking, it'll look another way. And so here's what a framing lumber stamp would look like and what there is about of it. Here's some mechanical properties that helps answer a question, but there's even more information about this. And here are some charts. So this is the strength of the lumber. And then there's all these adjustments and this and that that we're not going to get into. We're not going to look at all this. But here are some, again, some framing lumber, timbers, more about that. Here's joists. Okay, so there's a lot in this product use manual. There are some quicker ways to get to it. This lumber design values tells you, it's pulled out from there and it tells you what some of those things are about. Dimension lumber by species. This tells you about each different species and what it looks like when you're looking at dimension lumber and what some of those splits and things look like. It's really, really good knowledge. And then there's lumber sizes if you're interested in just knowing how big things are. And that's really important because when you say a 2x4, it's not 2 inches by 4 inches. It's milled to 1.5 by 3.5. Okay, and you can see that these ones are basically 1/2 inch smaller up through 6. So a 2, 3, 4, 6 are generally 1/2, and then the 8s are 3/4, 10s are 3/4, and 12s are 3/4 smaller. Okay, so there's a little bit about what you're going to do in here. And again, we're going to add images. Now, here's an interesting one. Summarize the important strength properties. So you're going to want to read about those in the strength portion and just make a quick summary. You know, it's a page and a half, 2-3 pages long, and I'm looking for you to condense that and pick out the key components we're going to look at. In the next section, we're going to talk about dimension lumber and span charts. So here again are the lumber sizes, and here are some wood strength charts. So these are the design values, and mostly in the table, I'll be asking you about extreme fiber stress in bending. Okay. Mostly, most structures in our area, the compression is we go so overboard. We put so many pieces of lumber in that we are far, far, far below the compressive limits. But that's so that we can put nails in at even increments. But these bending stresses, that would be for a top plate, a sill plate, a joist, a rafter. Those ones are also important, so we want to know about those. And then there are how far apart can the piece span? How far apart between the ends? And the way you read this, I'm going to make it a little bit bigger for you. Okay. This number here that you see down here is the span in feet and inches. So this is 11 feet 4 inches, 9 feet 9 inches, 15 feet 1 inches. And you pick the species, the grade, and then how far apart the joists are. 12 inches on center, 16 inches on center, 19.2, 24, and then what size lumber you're using. So with all that together, you have a standard span that you can use. So there has to be the joists have to sit on supports that are no more than 10 foot 2 apart, as an example. Okay, So these are for floor joists, but they also work for other joists too. Ceiling joists have their own, okay, and roof rafters have their own. And this one is for like there's a snow load and a dead load. Okay, so that's how you read these, and you'll be asked to do that. So remember, you look up the type of wood, the species, the grade, the size, how far apart they're spaced, how far between the joists, and this number here is the span, how far apart from the ends of the joist. How long can the joist be? Okay, so you'll be asked to fill out a table about that and then put in some things, and you'll be asked to compare some bending. And this is an interesting one. It's a little counterintuitive. So, as an example, usually the bending stress for a 2x4 is stronger than the bending stress for a 2x10. Now, that doesn't mean it can carry more of a load. Okay, because this is bigger, it has a bigger area. Okay, it can still carry more load, but the actual stress, pounds per square inch of the material, is less. Okay. And it's counterintuitive. There's some information about it. But what it boils down to is you can't see inside to see all the defects on a 2x10, whereas in a 2x4, you can pretty much see the defects. So they derate it just in case there might be extras. Okay, and then in 7.3, we're going to look at, instead of 2x4s and 2x6s, we're going to look at a special thing called an engineered wood product, and we're going to talk about joists. And you'll get a chance to see what they look like, but here's what an engineered product joist is. There's a piece of engineered wood board that's thin and up and down. Okay, and then there's some laminated wood on the top and bottom, and that fits into a slot. And we know from mechanics that long and thin and tall is very strong. It would be very weak in this crosswise direction, but incredibly strong in this up and down direction. Okay, so this is a way to get good strength with using less wood. And so you're going to look at that a little bit as we go and answer some questions. Okay, so you're going to look at it and kind of talk about some of the information, and then you're going to do a comparison of the tables and then add some images. You're going to use the I-joist table and the dimensional lumber tables and just compare the two. Okay, in the second week of the unit, we'll talk about the labor and we'll talk about wood damage. So there we go. That is your overall summary for what we're going to do in the first week of the wood product research.